Alright, so in this problem, I have x to the power of 9 plus x to the power of 6 is equal to 36. So to solve this, I'm going to first start by rewriting this as x to the power of 3 times 3 plus x to the power of 3 times 2 is equal to 36. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 3 is going to equal x to the power of 3 to the power of 3, and x to the power of 3 times 2 is going to equal x to the power of 3 to the power of 2. Now I'm going to let x to the power of 3 equal to the variable y. So if I substitute in y for x to the power of 3, I get y to the power of 3 plus y squared is equal to 36. And if I subtract 36 on both sides, I get y to the power of 3 plus y squared minus 36 is equal to 0. So to solve equations like these, we actually have to first find one solution to that equation and then use that one solution to find the remaining solutions. So how are we going to find that first solution? Well, the only way to actually do that is to just plug in values and see if they work. So we're going to first plug in x equals 1, and if x equals 1, we get 1 to the power of 3 plus 1 squared minus 36, which is equal to 2 minus 36, which does not equal 0. For x equals 2, I get 2 to the power of 3 plus 2 squared minus 36, which is equal to 8 plus 4, which is 12 minus 36, which again does not equal 0. Now I have x equals 3, so I get 3 to the power of 3 plus 3 squared minus 36. 3 to the power of 3 is 27. 27 plus 3 squared is 9, so 27 plus 9 is 36. 36 minus 36 does equal 0, so this is right, and x equals 3 is the solution. So now that I have x, actually, sorry, this should be y equals 3 as a solution. What I have to do is divide y to the power of 3 plus y squared minus 36 with y minus 3. So to divide these two, I'm going to have to use synthetic division. And if you guys don't know what synthetic division is, I recommend watching a video on it. But basically, we have our coefficients of our numerator here. The first coefficient is 1, the second one is 1 as well. We're supposed to have a y here because our exponents go in order, decreasing, and we don't have y to the power of 1 here, so we just say 0. And then finally we have negative 36 at the end. And then our denominator, we have 3. So now we're going to drop down 1. 3 times 1 is 3. 1 plus 3 is 4. 3 times 4 is 12. 0 plus 12 is 12. And 3 times 12 is 36. Negative 36 plus 36 is 0. So I have a remainder of 0. And these are going to be my coefficients for my problem right here. I have x squared plus 4x plus 12. Sorry, this is actually y squared plus 4y plus 12, meaning that this is equal to y squared plus 4y plus 12, and also this means that y minus 3 times y squared plus 4y plus 12 is equal to 0. So now this gives me two equations. I get y minus 3 is equal to 0, meaning y equals 3, and we already know this. And I get y squared plus 4y plus 12 is equal to 0. And to solve this, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 4, and c is 12. So I get y is equal to negative 4 plus or minus the square root of b squared minus 4ac. B squared is 4 squared, which is 16. minus 4 times a, which is 1, times c, which is 12, all over 2a, so 2 times 1, and this is equal to negative 4 plus or minus the square root of 16 minus 48 over 2, which is equal to negative 4 plus or minus the square root of negative 32 over 2, and this is equal to negative 4 plus or minus the square root of 32 times the square root of negative 1, which is the same thing as I, over 2. And the square root of 32, this can be simplified to the square root of 16 times 2, which is equal to the square root of 16 times the square root of 2, which is equal to 4 root 2. So this is going to equal negative 4 plus or minus 4 root 2 I over 2. And if I divide both of these terms by 2, I get negative 2 plus or minus 2 root 2I. So I have 3 solutions of y. However, we aren't done yet because remember, I let x to the power of 3 equal to y. So I get x to the power of 3 is equal to 3. And I also get x to the power of 3 is equal to an imaginary number, which we actually can't do, so we can't use this equation. So the only solution I can use is y equals 3, and to solve this, I'm going to take the cube root on both sides. The cube root of x to the power of 3 is x, so I get x is equal to the cube root of 3. So this is my solution to this problem. And remember, whenever you're solving problems like these, use synthetic division, so you always have to find one solution first and use that other solution to find the remaining solutions. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 times 3 to the power of 33. So to solve this, I'm going to first rewrite 2 to the power of 22 as 2 to the power of 2 times 11. And I have this times 3 to the power of 3 times 11. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this turns into 2 to the power of 2 to the power of 11 times 3 to the power of 3 to the power of 11. Now 2 to the power of 2 is 4, so I get 4 to the power of 11 times 3 to the power of 3 is 27, so 27 to the power of 11. And now if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this turns into 4 times 27 to the power of 11, which is equal to 108 to the power of 11. So this is my answer.